Lot of companies have used TOC. Lot of companies, thousands of companies have used TOC. Go online and look for results. You will find tons and tons of YouTube videos and results. I'm actually going to show one to you today, applicable to IT. So now let's talk about what is TOC. TOC is, if I draw a line and call it a system, every system has some things inside, call that inventory. All the stuff that has not yet been produced. You put operate, this is probably not working. Okay. So there are three things in the system we need to worry about at a highest level. That the system is there to generate or meet certain objective. In case of business, it may be to generate throughput and generate money. Right? There may be non-profit organizations where the throughput may mean something else. So there is an inventory. You work on an inventory with operating expense and you produce throughput. The objective is to increase the throughput. The objective is to decrease the inventory. A lot of times people also think about objective is to decrease the operating expense. Right? Ideal case would be to decrease the inventory, increase the throughput. Now the application from supply chain perspective, like you were saying, one of the things in supply chain is how do I decrease the depth? How do I increase the width? Right? If you're dealing with simple supply chain and distribution, then it's about how much inventory do I have, right? And how do I reduce that inventory? Within this system, there are stuff, we call it a organization with multiple departments. The objective is to increase the flow inside the system. If we increase the flow, then we can decrease the inventory. One way to look at it, right? This is how I would describe, this is a very simplified view. Now, how do I manage the system? Let's break this flow down into something like this. It's a very simple, even dumb example. In this example, there is raw material, so RM1, RM2 are raw material. A, B, C, D, they are all workstations. And then when J produces, you have a finished product. That is something that you can sell. If you look at this handoff from A through J, where do you think, what is the output of this factory? What do you think this factory can produce? Tell me.
So what can be what the output?
So I may not have explained this. A can produce 9 per hour. Let's say 9 widgets. Right? B can produce 10 widgets, then 6 and 12 and 12 and 15, right? This is the rate at which each workstation can produce. It could be synonymous with machines on a manufacturing floor. It could be projects in different departments where they are doing different tasks, and this is the rate at which they can produce. This is their capacity in some sense. What do you think the output of this factory is? 6, right? And which machine determines? It's C, right? But now, given this knowledge, it kind of becomes a very powerful thing for us. Because now, if we say demand is 24 red and 24 blue for this factory, right? C produces 6 per hour and our total demand is 24. What happens if machine C breaks down? So for the time it will break down, you will not produce, right? So anytime C does not produce, what is happening? You're not making money. What happens if A breaks down? Not really, right? Because you still have some protective capacity, right? Because if C breaks down, see, the total capacity of the system to produce is 6, right? But if C breaks down, what is going to happen? You're going to produce less than 6. But if A breaks down, you may still produce 6. Right? So it's a different, if let's say E breaks down, it may not impact for a long time. Right? So what does it mean? What did we just conclude with? This just very simple example, right? That knowing where the constraint is, it gives management a focus that if we make sure as managers or as management that C is running all the time, we are making money all the time. But that's not what happens normally, right? If you focus everywhere, tell me what will happen. If let's say I am a manager at E and my behavior is let's just focus on producing E, what will happen?
Have too much inventory.
Too much inventory. We are producing at E15, we are producing at F12. Everybody is trying to produce more and more because that's what the good performance looks like, right? But we are not making money with that. Because in the end, money is being made only if you, at the rate of 6. Right? So when we work harder, we are asking everybody to work harder, it just produces inventory, it does not produce throughput. Okay? What else can we do? What we are talking about 2 steps, right? Up to now, what did we do? The step 1 was what? We identified the constraint. Right? We looked at the whole flow and we said, what is it that governs the throughput of the system? And we said, see, what was that step? That step is called, you go and look at the system, identify the constraints. Sometimes it is easier to identify. How? You can just look at the load to capacity picture. How much is the load? What is the capacity? Sometimes it's simple, not all the time. Once you identify, what is this step? Now you're saying, how do I make sure that C produces 6? Because 6 is the capacity. Most of the time we find that C is not producing 6. C is actually producing 4. So what do? We do something called exploitation. That means, what are the exploitation steps? C should always work on the right stuff. C should never go idle. C should offload non-value added stuff. Right? If C is to walk here and pick up a material and then walk back, all this is waste, right? Somebody else should be walking on behalf of C and doing that. The C should be just here and getting material and then doing the work, right? That is the most efficient way C can produce. Because when C works, you make money. So that is, what else can we do, right? How do we protect constraint from disruption? So if we were to put in a quality control process, let's say, where would you put it in the system? Think about it.
Repeat the question.
Sorry?
One more time the question, please.
If you were to put in a quality control process, where you should necessarily put it in this flow?
In between B and C.
In between B and C, right? Why? Is that clear? Because anytime machine C goes and reworks something, it's a waste of capacity, right? So if something that has not been quality checked goes through C and it is not good, it comes back, your throughput is hurt, right? What else can you do to protect C? C has to continue to run. So what else can you do? If at all there needs to be a queue or buffer in the system, where will it be? Right here. Because if you have some queue in front of C, you are making sure C never runs dry. Make sense? So up to now, all the time what we have been talking about is we identified C as a constraint. All the actions that we are taking is to make sure C is running all the time. And important fact is when C works, we make money because that is a constraint. Okay, so let's say we have set this up, but there are other people in the organization, other people in the company. How should they work? We have a good rule for C now, for the constraint. So any ideas, how should other people behave? Other departments behave? Because before, they were just behaving differently, right? Their metrics was produce as much as you can because that is what makes you look good, right? Now, what does it mean?
Is it that they should limit production so that they don't produce more than C?
So there should be some way of connecting C or giving a signal from C to everybody else, right? So what does this mean? It means that everybody else has to work just to make sure that we are not depleting this buffer. So for example, machine A can work at 9 per hour, but should work only when there is 1 that is taken from the buffer. That's the only signal. That's it. Any other time, if you are doing more, any other rule will not work. You're going to flood the system. The inventory is going to go up. It's not going to produce. It's a waste. This is the third step. It is called how does the entire or the other organization who are not constrained subordinate to this action or the decision that we have taken, that this is a constraint and this is how it will work. So the exploitation steps are make sure these work and take all the steps in this. If you have to produce 3 reds and 4 blues and so on and so forth, if there is 2 red, 1 blue, 1 red, 2 blue, if this is the sequence, that is what the constraint has to work. No other sequence. Everybody else has to just follow it. Right? This is where we are saying this is how the entire organization should work. Identify the constraint, exploit the constraint, subordinate to the constraint, or the decision that you have taken based on what the constraint is. Now, at some point, when you run this, it becomes a very stable operation. And I've seen it many times. Why is it stable? Because the manager comes and focuses only on one play, on the constraint. Right? Everywhere else, there is a lot more room for things going wrong. You can recover. Let's say you are running this and now the market need is more than 6. Then what happens? Then you will have to make an investment to increase the C from 6 to some other number, right? To the higher number. Let's say you made that investment and then this C became from 6 to 12. What does this mean? This means you have now elevated the constraint capacity. This is step number 4. You have elevated because the market demand is much more. And in order to meet that, you have changed it. What are the implications of that now?
Constraint moves.
Move to A and B.
But think about it, it's not a very, I think it has a huge implication on the organization. The whole organization was running in a very stable state with C as a constraint, and everybody came to office and saying, okay, is the C running or not? Are we releasing material to satisfy C? We're very simple rules, right? The moment you change that, and let's say C became 12, your constraint moved to A. The rules change. In practical terms, the rules have changed. So that is why they say if you don't have a constraint, it's better to have a constraint. Identify it so that you can run an operation smoothly. It's actually good to have a constraint. Some people think and say that, oh, we shouldn't be having any constraint. It's actually good to have a constraint. Right? These are the 5 steps of TOC, theory of constraints, that you can continue to do this. You can identify the constraint, you can decide how to exploit the constraint, you can subordinate everything else to the above decision, which is what decisions did you make on constraints, elevate the constraint, and then go back to one. You can keep doing it to take the company to the higher and higher performance level, whatever the goals are.